we're going to look at how a transformer works in this lesson. Now, we looked at the structure of it last lesson. What it's made up of are two coils which are completely separate and an iron core through the middle bit. Now, earlier in this topic we looked at electromagnets. An electromagnet is made up of a coil of wire with an iron core in it. That's what makes it strong. And if you remember, we had three things that made an electromagnet really strong: the number of turns, the voltage or current, and having an iron core. So on this one, what we want to look at is what happens when you turn an electromagnet on. So on this one I have put on a DC current to it. And when I flick the switch, watch what happens on the meter. So it went up, but then it's gone back down to zero. This is still on, but the reading has gone back down to zero. And then I'm going to switch it off. But it's gone the other way now. And then it's gone back down to zero. So when I turn it on, it flicks one way. And when I turn it off, it flicks the other way. But why? If you remember all of the last few lessons that we've done, the primary coil here is connected to a direct current. So when that current is flowing in it, it becomes an electromagnet. That's fine. And while it's switching on, that magnetic field is getting stronger. And then it stays at a constant value. If you remember about our generating electricity, what we had to do is move a wire in a magnetic field. We moved it into the magnetic field and out again. We made the magnetic field stronger than weaker. So when we moved it in, the magnetic field became stronger, and when we moved it out, the magnetic field became weaker. But we only got the voltage generated in the wire when the wire was moving, when the wire was going in and out of the field continuously, or when the field was getting stronger and weaker and stronger and weaker, when it was changing all the time. When we turn this on, the primary coil, the magnetic field from that, gets stronger, but then it stops. And when we turn it off, it gets weaker, and then it stops. So it's only when we turn it on that we get a voltage, and when we turn it off. So when we turn it on, the magnetic field is increasing, and while that magnetic field in the primary coil is increasing, it's able to generate a voltage in the secondary coil. But once it reaches a steady level, it doesn't happen anymore. It's only when we turn it off, when the magnetic field is decreasing again, that we get a voltage induced in the other direction. So if we could make it turn on, off, we could actually continuously generate a voltage. But what type of voltage would it be? Would it be AC or would it be DC? Well, because it's continually changing direction, going one way and then the other way, we would be generating an AC voltage. What we need is for our magnetic field to change continuously, not only when I switch it on and off. And the only way to do that is to use an alternating current. Now this poor meter won't be able to cope with that. It would be trying to change backwards and forwards 50 times a second, and it would just shake. What we're going to use are the AC connections on here. So over here I have a different transformer set up. And what I'm going to do is to plug it into there and read the voltages off our 2 meters. So this voltmeter is connected to the primary coil. This voltmeter is connected to the secondary coil. So when I turn it on, I'm putting about 10 volts into my transformer. And I'm getting out of my transformer, you can see it, about 20 volts. This one is connected to the secondary coil. So I'm going from 10 volts to 20 volts. And how am I doing that? It's all to do with those turns again. If you remember, you got a stronger magnetic field when you had more turns, and also when we generated electricity, we got more electricity generated when we used a larger number of turns. So here I have 1,200 turns, and here I have 2,400 turns. By multiplying up the number of turns by 2, I multiply up the voltage by 2. So we need to summarise two things. When you use a transformer, the changing, alternating voltage in the primary coil makes this into an electromagnet, a changing electromagnet, one that's constantly getting stronger and then weaker. This is transferred to the secondary coil because the iron bar is there, because that becomes a magnet too. And because this secondary coil is in a changing magnetic field, a voltage is induced. They only work on AC. They don't work on DC, because DC doesn't change value. It only changed when we turned it on and off. The other thing we have to remember is the fact that the voltage that is changed in the same ratio as the number of turns on each coil. If the number of turns on the primary coil is multiplied by 2 for the secondary coil, the voltage is also multiplied by 2.